Alright, so tonight, or you're going to kind of continue what you were doing in class with that Desmos activity, where you're looking at the various translations that can happen with both sine and cosine, as well as what we will learn later, tangent, cosecant, cotangent, and secant. So the first kind of transformation we can have is a vertical shift. So what I'm going to do is just go over an example of each type of transformation here tonight, and then tomorrow we'll do another one of each one just to make sure you guys are okay with your transformations. So the first one is a vertical shift. So when our equation has something added outside of our cosine or sine function, that's going to tell us our vertical shift. So if I have something like y equals sine x plus 3, right away I know I'm going to be shifting, and I'm going to be shifting up 3. So one of the things that I would encourage you to do is to make a list of your transformations or things that could change. So we talked about amplitude already. Now we're talking about vertical shift. So our amplitude is 1, because there's a 1 in front here. Our vertical shift is up 3. And now we haven't learned horizontal, or we haven't gone over horizontal yet. And then we're also going to be learning about our period shift, or otherwise known as a phase shift. So right now we don't have a horizontal, and our period is still a length of 2 pi. So your period is the length from the start of your graph to the end of the first period of your graph. So right now the only thing that we're changing is our vertical shift. So when we go to draw our graph, we normally would start for our sine graph at 0. So before I even get started, I'm actually going to go ahead and make my x-axis. So I have 2 pi, half of that is pi, halfway between 0 and pi is pi over 2, and halfway between pi and 2 pi is 3 pi over 2. So I have my 5 key points, 0 to 2 pi, and then the quarter markers in between. So 1/4 of the way, half the way, 3/4 of the way, and all the way. And so what we're going to start with is our vertical shift. So normally we would start off at 0, but we're shifting up 3. So instead of starting up at 0, I'm making my new horizontal axis, or my new middle line, is this right here, shifted up 3. So when I go to draw my points, I'm going to start here at my new 0, and I know I have an amplitude of 1, so at pi over 2 I'm going to be 1 above that line. At pi I'm going to be back on that line. At 3 pi over 2 I'm going to be 1 lower, and at 2 pi I'm going to be back on that line. So by drawing that dotted line, we're shifting our whole graph up 3, but the graph itself is the same around that horizontal, our new horizontal line. Okay, so that's one type of shift, and that's just shifting it up and down. If the 3 was negative, we would have done the same thing, just shifted down 3. Our next type of shift is the horizontal shift. And so the horizontal shift, when you have, whoops, not plus, y equals, when you have something like y equals cosine, and then you have x minus c, this here is going to tell you how far you shift left or right. And one of the things that you want to look at is, or remember, is that if it's in parentheses, it actually goes the opposite direction. So because this is minus, that would be to the right the C amount. If it's a plus, you go to the left. And that idea is pretty consistent in all of our graphing from last year and this year. So if we look at the graph of y equals cosine x minus pi. So just like before, I'm going to start my list, my amplitude, my vertical shift, my horizontal shift, and my period if I have a change. So my amplitude is 1 because I have a 1 in front. I don't have a vertical shift because there's nothing being added outside of my cosine. Now my horizontal shift. So I have x minus pi. So that means if I were to go pi to the right, that's where my new starting point would be. Now, again, we haven't done any kind of period change yet or talked about how to change that. So the length of our graph from start to finish is going to be 0 to 2 pi. So then we can go to our graph. I didn't have a horizontal shift, so I can go 1 to -1, because again, that's just something we know about the parent graph. So now, this is where I'm not sure how you guys learned it in the past, but we always say you start where your horizontal shift is. So start at the horizontal shift. So I'll mark my pi, and then I'm going to add 2 pi to my starting point. So pi, I'm going to add 2 pi, which gives me 3 pi. So my graph is going to be from pi to 3 pi. If you wanted to keep it around the origin, you could subtract 2 pi and go that way. They're the same thing, they're just different intervals of the same graph. So then from here, we would start at pi and end at 3 pi. So I need to find my key points just like I did up here. So if I think about the halfway point between pi and 3 pi, I get 2 pi. And then what's halfway between pi and 2 pi? 3 pi over 2. And then what's halfway between 2 and 3 pi? That would be 5 pi over 2. So our key points are found by just finding halfway marks. So start, end, halfway, halfway, halfway. So now we can just kind of follow our pattern because we've taken care of the horizontal shift. Our period is taken care of because we've got that marked out. So now it's time to draw our graph. So for cosine, we start up at 1. So at pi, we're going to be up at 1, come down to 0. Then at 2 pi, we're going to be down here at -1, back to 0, ending at 1. Connect the dots. You have your shifted cosine graph. So again, you want to start wherever your horizontal shift is, and you're going to end at whatever your horizontal shift is plus your period, whatever that is. And like I said, we're going to do an example next about how to change your period. So again, these are 2 transformations that I know you've seen before because we talked about it in class. So these are the 2 that should be a little bit more review. Okay, the last one that we're going to do is the period change. Yeah. All right, so a period change. So in the Desmos activity, they kind of introduced you to this idea of squeezing your graph together and pulling it apart. So when we have what's called a phase shift or a period change, Teachers call it both things, so that's why I'm going to use both words. So when we have a period change, we want to, first off, we have a formula to help us with period changes. For a period change, your equation, that's when you have something like sine of b times x, all inside. So when you have something being multiplied to your x, that's your period change. So the formula for your period change is 2 pi divided by whatever you're multiplying by. So whatever the multiple is here, that's what you divide by, and that will give you your new period if it's changing. So this is your formula that you're going to use to help you determine, are you going a distance of 2 pi from start to finish, or did that distance grow, or did it shrink? So the one that we're going to do to practice is y equals 5 cosine 2x. Okay, so we're going to make our list just like we did before. So we have our amplitude that we're going to look at, which we can say because of that number there is 5. Vertical shift, there's nothing being added outside, so we don't have one. There's nothing being subtracted inside, so we don't have one. So for our period change, we're going to take 2 pi and we're going to divide it by whatever number is right here. So 2 pi divided by 2 means our period is going to shrink to just pi. So that means we're going to start at 0 and we're going to end at pi instead of 2 pi. So this is an example of how we're shrinking our graph. So instead of looking like this, where it goes 0 to 2 pi, we're going to shrink it so all of this happens, or squeeze it together so all of it happens between 0 and pi. Okay, so once we have this information down, we can go ahead and sketch our graph. Let's see, I do have an amplitude of 5, so I want to make sure that I can go 5 up and 5 down. And I could just do that around 0 because I didn't have a horizontal shift. Now, I'm not going to require that you write all of these little marks in the middle. You can if you want, it's not wrong. But I just care more about the key values, so 5 and -5. So now on my x-axis, my start, since I don't have a horizontal shift, is at 0. My end is going to be at pi. So now I'm going to go and find my key points. So what's halfway between 0 and pi? Pi over 2. What's halfway between 0 and pi over 2? Pi over 4. And then what's halfway between pi over 2 and pi? 3 pi over 4. So the only thing that really is changing with how we do a phase shift is what we label our x-axis. Because now we're not labeling 0 to 2 pi, we're labeling 0 to pi with our 4 key points, or 5 key points I should say. Once you have those written, the cosine is going to follow the same pattern. So we can follow the same pattern of a cosine. So we know that it starts at 0, it's going to start up at the highest point, which in this case will be 5. It's going to go through the x-axis at the next key point. In the middle, it's going to be at its lowest point. Then it's going to go back through 0 and end up at 5. So we would have our graph like this. And this is why it's really important that you label everything. Because if we don't label, how do we know what you changed or what shifted? So labeling is going to be what tells us what your shift is, if it's a phase shift, if you have an amplitude change, or anything like that. So tomorrow in class, we're going to do one more of each one. And actually, we're going to do some that have combined. So we're going to do some that have a vertical and a horizontal, or a horizontal and a phase shift. We're going to mix up a couple all in one problem, and we'll do those in class before you guys get started on your assignment.